Hi, my name is Kevin Postrike. In this video, I will demonstrate one of the primary use cases for IBM WebSphere Automation, which is proactive CVE protection for WebSphere and Liberty. CVE is common vulnerabilities and exposures for which various editions and versions of WebSphere and Liberty servers could be vulnerable. First, I'll do a short introduction to set up the proper context for the demonstration. IBM WebSphere Automation is a separately sold product that works with WebSphere Application Server and Liberty. WebSphere Automation's purpose is to automate the day-to-day routine actions that WAS administrators and operations teams find themselves burdened with. By helping automate these operations, we can give these teams back precious time that they can use for their organizational strategic initiatives. WebSphere Automation was designed based on customer feedback, and through that feedback we found common themes emerged. WebSphere teams needed help securing, healing, and optimizing their existing and future environments. WebSphere Automation addresses our customers' top concerns, which is understanding the overall security posture of their WebSphere environment from a single consolidated dashboard. An operator can see all of the unresolved security vulnerabilities in their traditional WebSphere and Liberty servers, as well as their IBM JDKs. This means there's no longer a need to manually evaluate each CVE against their environment, which can be a rather daunting task, especially for customers that have hundreds or thousands of WebSphere servers. By providing email-based notifications, teams can be notified within their existing workflows when a new vulnerability is detected or when a new vulnerable server is registered when IBM publishes a new security bulletin that impacts a registered server. These notifications identify exactly which servers are affected by the vulnerability so that teams can take immediate action without having to guess or spend time evaluating which of their servers are impacted by a specific CVE. Best of all, teams can register their existing WebSphere environments without installing additional fix packs or iFixes because we meet customers where they are, which is predominantly WebSphere ND on virtual machines in the data center. Additionally, that single consolidated dashboard provides up-to-date inventory tracking. We found that many customers manually maintain spreadsheets or custom databases for this information. With WebSphere Automation, inventory information stays accurate and up-to-date. It can be exported as a spreadsheet or integrated with existing tools using the REST APIs we provide. WebSphere Automation also provides automated vulnerability remediation, which fetches and installs a recommended fix pack or iFix to resolve the vulnerability. Now WebSphere administrators can easily roll out patches to their affected servers in a single click. Additionally, WebSphere Automation maintains the fix history of the WebSphere and Liberty servers. This provides the proof that servers are compliant according to their corporate security policies and service level agreements for patching critical security vulnerabilities. Many WebSphere customers suffer through this pain point and they want a solution. Most everybody can probably put themselves in the WebSphere admin shoes and can recognize why IBM WebSphere Automation would resonate with them. If you're not familiar with how some WebSphere operations team manually manage their WebSphere inventory and security posture today, I'm going to do a quick description of what the as-is process is today. This will help you visualize and better understand how IBM WebSphere Automation will help existing WebSphere customers remove the manual toil that they find themselves in today. First, the basic flow is that the operation team gets a generic IBM security notification that there's a vulnerability in WebSphere. As a WebSphere admin, I have to read and understand the security bulletin to learn about the risk exposure, details of the vulnerability, and possible remediation actions. Then, I have to correlate that with my WebSphere environment inventory. Many clients say they have spreadsheets that track all of this information, so that when they get these security notifications, they do that correlation and decide, does this matter, and which servers are impacted. Then usually they talk to a security focal in the organization to decide if they need to patch this now or if it can wait until the next fix pack at some point in time. Whenever that is, they'll deploy the fix, either a fix pack or an iFix. As soon as they change the environment, they have to manually update that spreadsheet again, and they usually have to provide that to some compliance officer or auditor to say, yes, we are compliant. The good news is, with IBM Automation, customers can eliminate all of this manual and burdensome work. Let me show you how. This WebSphere Automation demo showcases the proactive CVE protection use case that I reviewed in the introduction. Now this demo does require some initial configuration to set up an SSH key, a secret, and a config map, for WebSphere Automation to securely access IBM Fix Central and the WebSphere server environment. And I've already completed that setup, which is documented in the setup section of the demo script. So to start the demonstration, let's go to the IBM Automation dashboard and just take a view of the WebSphere inventory that we have right now under the application runtimes. So as you can see at the beginning of this demonstration, I don't have any WebSphere or Liberty servers registered with IBM WebSphere Automation. So before I register a server, what I want to do is set up a notification. As we discussed earlier, the notifications is an important aspect of WebSphere Automation in that as vulnerable servers are registered or new vulnerabilities are discovered, then the WebSphere operations team can get notifications of the servers impacted. So here I'll register my personal email address, and so because I've already have the email server configured in this environment, as notifications come, they will be sent to the email address that I've just configured. So now let's register our first WebSphere application server. In order to register a server, WebSphere Automation needs a couple of pieces of information. He needs to get the metering service URL, which is the service that's used to register the WebSphere servers. And it also needs an API key, which is used to authenticate the WebSphere servers during the registration process. And then it runs, in our case, a WSAdmin script that will automate the tasks for registering a server. What I've done for this demonstration and provided in the demo script are some convenience scripts to register and unregister a server. So I'm going to run the convenience script, which automates all the tasks and will automatically register the server for us. Passing in the server identification that's expected for the script, which is going to register a WebSphere traditional version 9057 server. So the script will go and gather the information as I mentioned, the metering service URL, the API key, and it will also make sure that the WebSphere application server is started, and if it's not, it'll start it. And then once the server is started, then it'll run the WSAdmin script that will register the server to WebSphere Automation. Once the registration script completes, we should see a message that the WAS usage metering property file was created on the server environment. So this is an indication that the server has been successfully registered with the metering service and thus with WebSphere Automation. So we return to the dashboard in IBM WebSphere Automation. We'll see that we have our 9057 server listed as a registered server. We'll also notice that WebSphere Automation has gone out and looked at the vulnerabilities that exist and mapped the unresolved CVEs to the servers, to the 905 server that we have registered. So in this case, there's a high severity, at least one high severity critical 10.0 risk level CVE and 32 additional unresolved CVEs that are discovered on this particular server. So because WebSphere Automation sends email notifications in the event a new server is registered that has vulnerabilities, I should be able to go and look at the email I set up. The WebSphere Automation did send an email notification indicating that my server has vulnerabilities discovered. And so for the purposes of this demo, we are going to isolate and focus on one particular CVE just to be able to understand the full value of WebSphere Automation in the end-to-end scenario. So in this case, let me select the server that we have registered and hone in on one CVE, unresolved CVE I should say, CVE 2021-26296. And because our WebSphere application server is vulnerable to this CVE and its status is unresolved on this particular server, we want to dig into some additional details to find out what it's going to take to resolve the CVE. one of the pieces of information that WebSphere Automation makes easy for us to get is the security bulletin. And the security bulletin is the document that IBM publishes that provides information about the vulnerability, its risk level, and the details about the CVE, but also provides remediation and fix options for this particular vulnerability. So in this case, if we look just at a small snippet of the document, we can see that for the WebSphere 900 through 9057, a recommended fix is to either apply an iFix, an interim fix, PH34711, or upgrade to a fix pack 9058 or later. So typically the WebSphere administrator and the operations team would take this information and understand its server inventory and determine if the server is impacted and needs to be patched for this particular vulnerability. As we can see, WebSphere Automation has already given us the information that indeed our server is impacted and affected by this particular CVE. And ultimately, the WebSphere administrator would then go off to IBM Fix Central, download the fix pack or the iFix into their data center, and use a process with Installation Manager to install the iFix or the fix pack on the server in a manual process. Now, WebSphere Automation provides easy access to be able to prepare a fix which will allow us to download the fix pack or an iFix that's recommended for this particular vulnerability and automatically fetch that from IBM Fix Central and install the fix directly to the server right from WebSphere Automation. For the purposes of this demo, selecting the iFix instead of the fix pack has benefits in that the iFix is going to be much smaller in size to download from Fix Central than it would be a fix pack. So for demonstration purposes, it makes sense to select the iFix. So in the option, we can choose either to fetch the fix, which will get the fix from Fix Central, store it into a Mongo database, in which case we could use the fix to install later, or we can fetch the fix and install the fix all in a single click. Now for this demo, I'm just going to break it down into two steps. We'll fetch the fix, which will get the fix from IBM Fix Central. So in this case, part of the configuration that I did ahead of time was I provided the IBM ID in the setup and configuration of WebSphere Automation, and that IBM ID has authentication to Fix Central to be able to download the WebSphere and Liberty fixes. So it'll take a couple of minutes for the fix to download, probably 2 or 3 minutes in the demonstration, but you can see the status changes as the action progresses. So right now it's fetching the fix. Okay, so once the fix has been downloaded and placed into the Mongo database for WebSphere Automation, at this point we're ready to install the fix if we want to, or we can install it later. So for this demonstration, I'm just going to quickly go to the next step and install the fix. One of the options we have is to decide whether we want to create a backup of the WebSphere configuration before we actually do the installation. Again, the backup is going to take a little bit of time. I'm going to skip the backup for the purposes of the demo and just proceed to install the fix. Now notice in my particular demo environment, when I do the install fix, I get this error pop up. Now I'm going to ignore the error because I know that it's not a real problem, and I know that because the status is changing to installing the fix as to coming back immediately into a failed state. So for some reason there's some issue in my particular environment that pops up this error that can be ignored for this demo. So the fix will take a couple of minutes to install, and we will wait for it to complete. So while we're waiting for the fix to install, I should just reiterate the fact that part of this setup that I did for this demonstration was to set up the IBM ID that had entitlement to WebSphere and Liberty fixes in IBM Fix Central, and also the SSH key that is used to securely communicate between WebSphere Automation to run Ansible playbooks that does the installation of the fixes into the particular server using Installation Manager. So this is a really big benefit to WebSphere administrators and the operations team that they don't have to manually go off and download fixes, store them, and then install them. We can just issue the download and install directly from a couple of clicks in the WebSphere Automation dashboard. And the value of that is that once we have this information of the fix being applied to a server, the security posture of my WebSphere application servers that are registered with WebSphere Automation are automatically updated with the new security information, the fix history, and when the patch was applied. And we'll take a look at that in just a couple of minutes. So once the fix has been installed, hopefully successfully, we'll get the status updated to installation complete. So that indicates that the WebSphere server has been patched with the iFix that we installed. So a nice feature in WebSphere Automation is also that we can look at the run books that are associated with the tasks that we ran. So in this case, installing the iFix, we can go to the run book and download the logs, or open the logs, and see what happened during the installation. Now, this is especially helpful and useful if in fact there was an error during the installation, in which case this is the log that you would go to find out what failed during the installation. So in this case, our installation is complete. No worries, we're happy. So the next cool thing to look at with WebSphere Automation is, now that we've applied the fix, we can view the updated security posture and fix history of the server that we've registered with WebSphere Automation. So in this case, we can drill into the server and take a view of the CVEs that are impacting that particular server, and we can sort by the status, meaning the CVE's either been resolved or it remains unresolved. And in this case, you can see the CVE that we just applied is now showing in the resolved state. Furthermore, we can look at the fix history and we can show exactly when the particular iFix, in this case, was installed to resolve the particular CVE. So this has given great value to the WebSphere admins and the security teams to know that their servers are being patched according to their security policies, right, and meeting their SLAs for patching high severity vulnerabilities within their application server estate. So that's a view of one server in our environment. What I want to do next is just quickly register another server and take a look at the updated inventory as we have multiple servers that are registered to WebSphere Automation, and an example of where one server has actually been patched for a known vulnerability and another server or set of servers, right, are not actually patched for their vulnerability. And the value of this is that we get to see the overall landscape and the security postures of all the servers in our estate, in that if we apply an iFix or a fix pack to servers, we can get a real clear view of which servers remain vulnerable and need to be patched versus those that have already been remediated. So running the same script that I ran earlier, I've registered a 9056 server, and back in our dashboard in WebSphere Automation, we'll see that the 9056 server is listed as a registered server. Now that we have two servers listed, I want to go back into the views, right? And let's take a look at the particular CVE that I was interested in. In this case, I can maybe drill down and sort by the CVE that I care about. So let me just filter on that CVE. And in this case, the CVE that I patched on the 9057 server is listed here. And in the security CVE view in WebSphere Automation, I can see that I have one server that's been fixed and I still have one server that remains vulnerable to that CVE. Drilling into the particular CVE, we get the view of the affected servers. And now that I have multiple servers registered, we can start to see a list of the servers that remain unresolved and the servers that are resolved. And again, having the option to go ahead and prepare the fix for the remaining unresolved vulnerabilities. So with that, I think that is the end of the demonstration. And I hope this quick tour of WebSphere Automation gives you a clear understanding of the value proposition of this automation to our WebSphere administrators and operations teams. Thank you very much.